So this is the promised video about the test that I told you I'd make. We're going to do these in sections. The first section deals with the matching part of the test. So I'm going to comment on these, and if possible I'll put this in two parts because I'm expecting a phone call. If it comes, I'll just stop in the middle. Okay, a region in space where an electron is found. Those are the orbitals like we talked about with the boxes. Remember the boxes, and 1s and 2s and 2p. One day we made a picture of that. We built a little atom, the 1s, and then the 2s is a little bigger, and the 2p's look like this. So the actual regions in space were these little three-dimensional shapes. They're called orbitals, and that would be C. An electron at a higher energy level than normal moved away from the nucleus. That atom is excited. That's me standing in the chair. So I gained energy, I moved up into a higher level. Then I came back down toward the nucleus, I'd be losing energy. So this means I was excited. The center of the atom, I think we all know, is a nucleus. And the nucleus would be O. Remember, I gave you these answers because you don't need to know those. You can tell I'm on hold here. Now the number of cycles per second, this had to do with this kind of a wave with a longer wavelength versus this kind of wave with a shorter wavelength. You notice there's more energy involved in this wave because it takes more energy to move the pencil up and down more at a faster rate. Okay, so the shorter the wavelength, the more energy the light has, and the actual number of cycles per second is called the frequency. So you come up to the choices here, and frequency is letter G. Now these subatomic particles don't have a charge. They're neutral. Those would be neutrons. Which ones had a negative charge? Was that protons, neutrons, or electrons? Electrons. So the negative charge would be F. Subatomic particles with a mass of 1 atomic mass unit that is positively charged. Positive. What was it, protons, neutrons, or electrons that were positive? So that was P for proton. Number 12, the radioactive decay. One day I walked behind the desk to show you that sometimes you could determine things by looking at indirect evidence. You remember, I don't know if you remember me walking behind the desk, and I walked right through, and everybody clapped. Then I walked through the other way, and it was very impressive. But then I ran into a trash can. So there was something behind the desk that you couldn't see. So the actual particles that were going through the gold foil are called alpha particles. They have 2 protons and 2 neutrons in them. So alpha particles is what Rutherford shot through the gold foil. And you don't have to know Rutherford's name, but you need to know what the alpha particle. So alpha particles are J.
Thank you for your patience. We are currently experiencing a higher than expected call volume. If you would prefer to receive
Each color of light,
from the next available.
remember this section up there. Hang on, this is where I'm going to stop and I'll continue.